after discussing about solid liquid extraction, now we go into discussion of the salt-slag extraction, which is for solid sample. So for solid sample, it's still the same like SLE, okay? Salt-slag extraction, the similarity between them is still using solvent, because at the end of the day we want it to be inside liquid form. But the difference between salt-slag extraction and SLE is the requirement of an apparatus that contain condenser and also porous apparatus over here. This is where you put your sample, your solid sample, okay, after you grind it into fine powder, you put it inside here, and then you put in solvent, okay, you put in solvent so that it is extracted under heat. Okay, so the solvent will go inside here and then will be condensed, and then this is where you collect all your extracted solution. Okay, this is your heating element. Okay, usually what was used is that oil or water. Okay, usually the extraction is maybe up to 110 degrees C only and below. Sometimes we can do at 70 degrees C, just the boiling point above some of the solvent. Okay, so this is what we call as porous thimble. Okay, so it is like timber actually. Okay, now next, let us see how does it looks like in real. I'm going to show you a video. It's a 3-minute video so that you can watch it and understand how it's done from the beginning until the salt-slag finish.
Hi, in this video I will demonstrate the oxalate extraction of capsaicinoids from spicy peppers. First you will need a baking tray, Pyrex glass containers, a cutting board, a sharp knife, and peppers.
So this is where he homogenized, he cut and grind.
From the peppers, saving the seeds. These seeds contain more capsaicinoids than the pepper flesh. Chop the peppers up, place them into a Pyrex container, then place them in the oven to dry on low. Once your peppers are dry, you will need 95% ethanol, a 100 milliliter graduated cylinder, a mortar and pestle, your dried seeds and pepper flesh, a oxalate extractor, adapter, and cotton balls, a hot plate with water bath, a 250 milliliter round bottom flask, and a condenser. Grind the seeds and the flesh up separately. Wear a dust mask if you have one. The increased surface area will speed up extraction. Take a cotton ball and stuff it down to the bottom of the oxalate extractor. Add boiling chips and 100 milliliters 95% ethanol to the flask, then fit the extractor. Add your down as necessary. Add another cotton ball to the top and pack down. Note that you must pack the peppers down so that they are not above the siphon side arm, otherwise they will not have compounds extracted as efficiently. Fit your adapter and condenser, adding cat clips as necessary. Raise your heating bath and add water. Begin heating. Use a heating mantle if you have one. This is a time-lapse shot over approximately 5 minutes. As the ethanol boils, ethanol vapors travel up the side arm on the far right to the condenser above, where the solvent condenses and drips down into the sample cup. Once the sample cup fills with solvent and reaches the top of the siphon sidearm, most of the solvent will be siphoned back down into the flask below. This process repeats, and as fresh, clean solvent vapors condense into the sample cup, the extraction continues. Each subsequent extraction continues continues to use fresh ethanol, increasing efficiency, but the total process uses only 100 milliliters of ethanol. Soxhlet extraction can be boring, but do not leave it unattended and make sure the heating bath does not run dry. Now here is a shot of another cycle draining. The extraction continues, and eventually you get a much darker colored solution. After vacuum distillation and overnight settling, you'll obtain a dark red/brown oil. You can try and pipette off the top layer, which contains ethanol and plant matter, but the rest of the vial is already dirty. The easy method is to place a pipette at the bottom of the vial and remove the oil layer. In the Eppendorf tube is the original dilute extract, and in the vial is the concentrate. To sample the taste, take 1 drop of the oil and 9 drops of distilled water or 5% sucrose and mix well. If you like this video, please rate, subscribe, and comment.
Okay. We finished watching the video on Soxhlet. Let us back to the slide. Okay, what can be concluded inside the video just now? Okay, so Soxhlet will take some time to extract all of the he's actually extracting the paprika compound, right? So it will take a lot of time to extract all within this condensing or Soxhlet apparatus that we call, including condensing, because it takes some time for the solvent that we put to actually collected again in the round bottom flask. Okay, usually the time used for Soxhlet extraction is between 4 to 16 hours. Okay, 4 to 16 hours for like that home lab or any R&D is okay, but what if it's in Jabatan Kimia Malaysia, Department of Chemistry of Malaysia? Okay, it will actually reduce the throughput of the analysis. Okay, so it's a great tool to extract the chemical compound, the organic chemical compound of solid, but we have to think on how to reduce the time consumed. Okay, and the second part is that it uses a lot of organic solvent. Okay, at least like 10 to 100 ml that I mentioned just now, whereby it's going to create waste disposal problem. Okay, if let's say you only want to take 10 microliter for HPLC, you are going to discard around 990 microliter from this 10 ml. Okay, so you're going to dispose that, and it's going to involve a lot of documentation in UTM at least. And then you have to do further concentration step because you are extracting out in a very large volume. Okay, it's very good to pre-concentrate them before you inject into HPLC if you don't want to have a very small amount of paprika. And also it is messy as well as pungent because you are using solvent for an organic sample. But is this Soxhlet extraction do no good at all? No, it is still applicable and it is still used in most of R&D labs. Okay, R&D labs whereby the sample is like 1 to 5 samples only. Okay, and it can be settled within a week. Okay, for the extraction, but for routine monitoring it is not recommended. It is better to use SLE. Even better to use micro SLE, whereby a small amount of solvent used. Okay, so let us see the steps in Soxhlet extraction and also extract cleanup. Okay, imagine that you have a 10 gram of wastewater sludge. Wastewater sludge is the residual solid inside wastewater treatment, and then you put anhydrous sodium sulfate, and then you add the solvent system, acetone, hexane. So in substrate extraction, you want to add a solvent, okay, that is going to produce 2 layers of your solvent and your sample. Okay, better yet is this is non-polar solvent. Non-polar solvent means that it does not contain any polar functional group inside it. For example, hexane, there's no OH, there's no amine inside it. So that's what we call as non-polar. And then you do salt slag for 16 hours, and you will get the filtrate concentrated. You put 1 gram copper powder to remove sulfur, and then undergo further silica gel cleanup, because at this time filtrate may be still dirty. After silica cleanup, you can go to GC analysis. Okay, and if you see over here, the volume of organic solvent is up to 320 ml. Okay, so this is how the sludge sample containing this dialdrin or this lindane are the pesticide. Okay, pesticide, you see that this is considered as clean chromatogram. Okay, because it contains all your necessary peaks, but only contain a very small peak of unwanted things. For example, all those things that goes into the silica gel cleanup. So that's why salt slag help you to reduce all this, and the silica gel cleanup further reduce the amount of interference. This is what we call as interference. It can be endogenous, means it's already inside that, or it can be contaminants outside of the sample during the extraction. Okay, I will stop here, and I will proceed with the next slide on how to sample prepare inorganic analytes. We finish on organic analyte. Okay, all these are this one.